Okay, here's what's coming at you tomorrow. 2x third minus 3x to the second plus 18x minus 27. Sorry, you can't really see that. Now, you need to factor that, but this time we don't have 2, we don't have 3, we have 4 terms. Okay, yikes. 4 terms, what you do, you don't worry about the GCF. Okay, I'm not, most of the time, because 99.9% of the time it's always 1. Okay, so that's a pointless step. So what I do is I set up a big box. This is a new box, and you write the word grouping. Okay, and here's how you set up a grouping box. You put parentheses, and then you need an addition operator, then parentheses. Then you're going to do the same thing, but you're going to put little spaces outside your parentheses. And then at the end, you put a line with a parentheses. You got to get used to that setup. And then after that's done, we're going to check for adopts. So 4 terms is always going to be grouping, and then seeing if we have a difference of perfect squares. So here's how you group. It's grouping for a reason. You group the first 2, 2x to the third minus 3x to the second, and you group your next 2, which is going to be 18x minus 27. Okay, now what you try to do is come up with the GCF for just each one. Now here, you don't need a negative because that's positive. You do need x, but not only do you need x, you need x to the second here, okay? And then 2 and 3, the only common factor of 2 and 3 is 1. Okay, you can't find another row with 2 and 3. So we're not even going to put 1 here. Okay, now you don't need a negative here. You don't need x because 27 doesn't have x. So 18 and 27, okay, I see those here. So that would be divisible by 9. Okay, now here's what I do. The x to the second doesn't just go away. That comes out here, and the 9 comes out here. Now, these should end up identical. So that's 2, drop the 2. Now, to divide x to the third by x to the second, we get rid of the smaller one and just subtract 2 from your 3, which would be 1. So you just put x. Minus 3, and those can go bye-bye. And that's going to be 2, the x stays, and then minus 3. Okay, so in each parentheses, we have 2x minus 3. We kick that expression out because it's like I'm dividing this and this, so they would cancel. And then I have x to the power 2 plus 9. Now, the one where the x doesn't have a power, the parentheses, you just write that off to the side, okay? Now, the one with the power, you have plus, so you can't do difference of perfect squares. So it's 2x plus 3 times x to the second power plus 9. This is all the factoring that exists, really, these types. Okay, my next problem, 5x. Again, all these have 4 terms. So again, the GCF out of 5, 4, 25, 20 would be 1. You wouldn't need a negative. You wouldn't need x because that didn't have x. So I make my grouping. And I put parentheses plus parentheses, and then lines outside of each one. And then here. But after grouping's been completed, you need to check to see if you have a difference of perfect squares. So grouping, I group the 5x to the power of 3 minus 4x to the power of 2. Then we have our plus, and then 25x minus 20. So in the first parentheses, we don't need the negative, but we need x. Not only do we need x, we need it to the second power, so I would be able to cross out the second one. See, if I just do regular x, then I'm not going to be able to cross out an x anywhere. 5 and 4, yeah, that would be just 1. So I'm not even going to put, you put 1 if you want. It's kind of stupid, though. Okay, I don't need the negative here. I don't need x, so 25 and 20, that would be 5, okay? Okay, so I factor out x to the second from that binomial and a 5 from that other binomial. And hopefully these are the same. So I drop my 5. I take out the second and take that down 2, so it's just a 1. So it'd just be an x without anything. Minus 4, and then those go bye-bye. And then that's 5 with x minus 4. What do you know? So outside here, you put the parentheses factor of 5x minus 4. That leaves me with x to the second plus 5. So the one without a power, we just write over here. There's no way that can be factored once it doesn't have a power. And then we don't even have a minus in here, okay? So the dots can't be done. So I have x to the second plus 5. Okay, moving right along. Put a 1 if you want. Okay, so 4 terms. I don't even worry about the GCF. I go straight to my grouping box. Grouping. That's the name of what you're doing. Okay, 3 is the AC table method, and 2 is GCF DOPS. But 4 terms is different. Okay. And then same thing, same line, you just put little spaces outside your line. And then we put 1x to the power of 3 plus 7x to the power of 2, and then positive 5x plus 35. Okay, negative, don't need it. You do need x though, and it needs to be to the second. You don't need the negative, you don't need x, so 1 and 7 would just be 1, so I don't put 1. Now, 5, 35, so that's in the row of 5. So x to the second is factored out, and 5 is factored out. So I get 1, delete, and that goes to just x, plus 7, delete. That's going to be the same thing, 1x plus 7. Okay, so I have identical parentheses of 1x plus 7. That allows me to factor that binomial out of the expression, and I have x to the second plus 5. Oops, I forgot my DOPS box, even though I'm not going to need it here. Okay, so the 1x plus 7, or x plus 7, okay, that's not even a minus, so you can't do the difference of perfect squares. So that's x to the second plus 5. Okay, and then finally, we have 1, 2, 3, 4 terms again. So I go to my grouping. And then set those up. So we have 1x to the power of 3 plus 13x to the power of 2. And then now make that plus negative, okay? So you're going to put negative 5x minus 65. So here you don't need the negative, but you need x, and it has to be to the second, okay? 1 and 13 is just 1. Here you will need the negative. You don't need x. You never do need x in that other parentheses. Then 5 and 65. Well, here's 5 and here's 65, so I could probably divide them both by 5. So I factor out x to the second, and I factor out negative 5. So it's going to be 1. Cross that out. Take that down 2, so it becomes just an x. Plus 13. Cross it out, and then that's going to be 1x. Remember, I'm taking negative 65 divided by negative 5 when I divide that. So negative divided by negative, which turns out positive. Okay, so I factor out the expression 1x plus 13. And then I have x to the second. Don't write plus negative. Quit doing that. Minus 5. Okay. So difference of perfect squares. So the 1x plus 13 just always goes over here. The 1 to the left will just normally go here. We have a minus. 5's not a perfect square. Okay, you add a minus at least, but 5, you can't get that to factor into a perfect square, so that's it. And I have x to the power 2 minus 5.